Today we're reviewing proportional relationships. Not too long ago we had a unit where we looked at equations, tables, graphs, and verbal descriptions. We could match all of them up and we could look at any of those and decide if there was a proportional relationship or a non-proportional relationship. So let's look at how some of this works again. On this first one right here I have a table complete. So I'm going to go ahead and graph these points on my table. I've got 0, 0. I've got x is 1, y is 50, x is 2, y is 100, x is 5, y is 250, x is 10, y is 500. So when I connect those dots, you'll notice I make a straight line, and I do pass through the origin of 0, 0. So straight line passes through the origin. That makes a proportional relationship. So let's go ahead and determine what my equation would look like for this. I've got y equals, and I've got to figure out what my constant is. I've got a straight line, so I know I have a constant of proportionality. Remember, we figure out our constant by putting y over x. So if I do y over x, 50 divided by 1, that's 50. 100 divided by 2 is 50. 250 divided by 5 is 50. So my constant is 50, and I put times x. So you have a proportional relationship in your equation if you just have y equals your constant times x. Okay? So this means anything we times by 50, like if x was 20, 20 times 50 would be 1,000, and that would be our y. Okay, on the next one, I just have the graph completed. I've got a straight line, but I do not pass through the origin. So it does not pass through the origin right here, not proportional. All right, but let's look at what our table and our equation will look like. All right, so if I'm filling in my table from my graph, I'm going to look at this first dot. I see that x is 0, y is 100. If x is 1, y is 150. X is 2, y is 200. And I can tell here I'm just going to keep going up by 50. Okay, so I have a constant rate of change here, but I do not have a constant of proportionality because 150 divided by 1 and 200 divided by 2 are going to equal different things. So we'll show that as y equals kx plus b. And b is whatever our y is when x is 0. So if we look at our starting point right here, x is 0, y is 100. Our b in this situation is 100. So we'd say y equals 50x, because I am moving by 50 for every 1x, and I put plus 100 because I start at 100 right here. All right, so we touched on this, a constant of proportionality, so we only have this when our y over x keeps equaling the same thing. So the constant of proportionality is the ratio of y over x is equal. And we have another example down here. If I do y over x for each one of these, 62 over 2, 124 over 4, 186 over 6, I will keep getting 31. Okay, in this last section, just a reminder that our x value is our independent variable. Our y value is dependent. And R here stands for unit rate. So in this situation, if I wanted to figure out my unit rate, my graph is labeled money and months. If I wanted to write an order pair for this, I'd put my X first, so 1 on the X equals 200 on the Y. And remember, with unit rate, it's also Y over X, and always money first. So money, 200 over 1. So 200 is our unit rate. We could write that as Y equals 200X. All right, so next, you're going to be doing a worksheet and a Google form just to review this topic.